In this video, we'll be looking at the derivatives of logarithmic functions. The rules are stated here. If you take the derivative of log base b of x, we get 1 over x times the natural log of the base. The derivative of the natural log of x is simply 1 over x. And then the two rules below that are including the chain rule. So if the logarithm's argument is not simply x like we see above, if it's the natural log of a function, we need to remember to multiply by the derivative of that function. For example, let's find f prime of x. Notice we are taking the derivative of the natural log, so that is 1 over the argument, x squared plus 10. But then we have to multiply by the derivative of that argument, which is 2x. So we get 2x over x squared plus 10. In our next example, we want to find f prime. And notice this time the log has a base of 5. So to take this derivative, we do 1 over the argument on the log, x e to the x, times the natural log of the base, and then we need to remember to multiply by the derivative of the argument. Notice that that argument is a product, so we need to use the product rule. First times derivative of the second plus second times derivative of the first. So here we simplify, we get x e to the x plus e to the x all over x e to the x natural log of 5. And notice that the numerator and denominator all contain e to the x, so let's factor e to the x out of the numerator. And we'll leave the denominator as it is for now. And now we can cancel those e to the x's, and we get x plus 1 over x natural log of 5. In this example, f contains a natural log function, so f prime of x is 1 over the argument on the natural log times the derivative of the inside of that log. So we need to multiply by the derivative of the argument using the chain rule. So we have negative e to the negative x, and then we need to use the product rule. First times derivative of the second plus the second times derivative of the first. Simplifying that brackets, we get negative e to the negative x minus x e to the negative x plus e to the negative x all over e to the negative x plus x e to the negative x. Continuing to simplify, the numerator e to the negative x cancels with e to the negative x. So we have negative x e to the negative x. And in the denominator, we can factor out e to the negative x, leaving us with 1 plus x. And since e to the negative x occurs in the top and bottom, we can reduce it, leaving us with negative x over 1 plus x.